Okay.
How many more times?
Count 'em.
Amen.
So we've got systemic versus pulmonary. We already talked about systemic. Systemic circulation is what? How would you define that? Gas exchange. Gas exchange in the body, right? Excluding the lungs, right? Because the lungs are going to be pulmonary circulation, pulmonary circuit. Okay, so first we define those two. Arteries, in terms of the pulmonary circulation, remember the arteries are deoxygenated, and in the systemic circulation, arteries are oxygenated. Okay, that's the funkiness that goes on. So if we look at the systemic versus the pulmonary, this side is showing the right-sided pump of the heart. Okay, so as soon as all blood gets back to the heart here, what are these two major vessels? Sending all used blood into the right atrium.
The vena cava?
The vena cava, right?
Superior.
Superior up here, inferior down here. Both of those deliver their blood into the right atrium. Blood travels through what valve? Tricuspid into
Right atrium, or
right ventricle, nutriment. And then pumped up through what valve? Almost. This is the aortic. This is the pulmonary semilunar. Into this trunk here. What do we call that? Pulmonary trunk. As soon as blood splits here into the pulmonary arteries, it's sent into the lungs. And so that's why we see here at the top of the lungs, we have blue blood. And then what are these webbed-like vessels here called? Capillaries. Good. So that used blood or high in CO2 blood enters the pulmonary capillaries. The CO2 is exhaled, the oxygen is inhaled, and then we see a bright red scarlet blood. That indicates high oxygenation if the blood is like bright scarlet red. So that blood is sent sent back into what chamber?
left atrium.
The left atrium. Good. Yep. And down through which valve? Bicuspid valve into almost left ventricle, right? Other one. And then pumped up through aortic semilunar valve into the aorta. And then the aorta distributes the blood throughout the body. Again, we're not gonna go through every single blood vessel in the body. We're just gonna hit the major ones. In terms of blood vessels in the neck that are important, what's this pulse point here? Carotid, right? That's one of your most important pulse points there. Okay. As soon as blood leaves the heart, remember this is a really, really high pressure. There's a really, really high pressure here in this artery. That's why the aorta, if you look at it under a microscope, it has the thickest wall of any artery in the body. But what layer of the aorta is specifically, what layer is thick? The media, right? The middle layer, the tunica media. As blood travels through all the arteries of the body, we get to another set of capillaries. But what's different about these capillaries? What's their name? Which circuit are we in here? Systemic, so they're the systemic capillaries. And what's different about their exchange than the... Yeah, they're sending... Right, oxygen leaves here, CO2 enters. So we still have a 1-to-1 ratio, it's just swapped in the systemic capillaries, okay? As blood exits the capillary, it enters smaller veins called venules. That word ULE, that suffix, just means smaller. And then as those veins grow in size, they become veins. And then the largest veins in the body are given that specific name, the vena cava. That means cave-like vein. Here again, small point, the smaller arteries in the body are called arterioles. Okay, those are the smallest arteries before you become a capillary. Those are the arterioles. Any questions on vessel structure or gas exchange or systemic versus pulmonary circuits? Okay. So let's talk about a couple special circulations in the body. First one we're looking at is the hepatic portal circulation. Let's think of it this way, every time you consume food, any meal, you introduce a certain amount of nutrients into your body. Well, with some places more nutrients than others. And you introduce also a certain amount of pathogens into the body, like small amounts of bacteria, small amounts of virus, maybe any sort of germ that enters with your food. Every meal, I guarantee you, at least one little germ guy gets in there. And you can thank your hepatic portal system for you not getting sick from that single germ. As the food gets broken up in the stomach and enters the intestines, the intestines' job is to absorb all the nutrients in the food. The stomach's job is to break down all the food. Right? We got big parts that we need to chop up. But as soon as that food is broken down into its smallest components, carbohydrates, lipids, and proteins, those individual nutrients are then absorbed into the bloodstream. And only up until that point where those nutrients are absorbed can you actually get any use out of those nutrients. That's where vitamin B12 deficiency, has anybody heard of vitamin B12 deficiency? B12, yeah, go ahead. What do you know?
I actually have it.
You have it. Okay, so tell me what is that and how do you fix it?
Usually your fatigue, rundown.
Okay, yeah.
I had the injections first, and then they put me on the vitamin B12 supplement.
So you said you're fatigued, run down.
Mm-hmm.
It's because you're anemic.
Right.
If you cannot absorb B12 into the bloodstream, then you aren't going to get the benefits of B12. B12 is an ingredient or a precursor, an ingredient to make hemoglobin, which is the portion of your red blood cells that carry oxygen. And you don't have the ability to transport that nutrient from your intestines into the bloodstream. There's like a blocked gate there. So that's just an example of an inability to absorb even one nutrient into your bloodstream can lead to bad effects in the body. But under most conditions, most of the nutrients are absorbed into the circulation and then sent to the liver, right? Why would you send all this blood to the liver? Liver is a filtration unit, right? The most enzymes in your body, pretty much the majority of enzymes in your body are stored inside your liver. And what do enzymes do? Break stuff down, right? So the enzymes in your liver break down not only the bacteria, but also help to break down the nutrients so that your body can use them. So if your body needs them right at that time, your liver releases the nutrients right after the meal. But if your body doesn't need that glucose right away, the liver will store that glucose for later use. So it's a storage tank as well as a rest stop for metabolism of those nutrients. And it fights off infections. So these are the major points of the liver. The liver, you guys are going to see the liver in every single system we study. Probably one of the most important organs in your body, if you had to label them of importance. Removal of toxins, and let's go ahead and answer this question. Responsible for directing blood from parts of the...
Can you say the digestive or the intestinal?
Digestive or intestinal, sure. Digestive tract to the...
Liver.
To the liver, good. Any substance or nutrient absorbed into the small intestine will get sent into the bloodstream. So that's the purpose of the digestive system, guys, is to just break down food to the point where we can absorb it into the blood. And then the circulatory system then takes over. I think that was too loud. I can play that game. So this is what it looks like. You've got a major vein here. Okay, I want you guys to circle this one in your PowerPoint. Hepatic portal vein is an important vein to remember. Hepatic portal vein is the vein that receives, the final vein that receives all this blood from the digestive tract. So what do you see? What do you see right here? What's this guy? It's that green.
Is that the gallbladder?
It's actually the gallbladder. Yeah, the gallbladder is it stores bile so that when you need the bile to digest food, you have it. That's also attached to the system. But if you have, let's do just a little bit of disease process. You've got a 60, 70-year-old male who is suffering from severe alcoholism. All right. And so what's going to happen to that? What's going to happen to that guy's liver?
It's going to be enlarged.
Cirrhosis.
It's going to become cirrhotic, right? What does that word cirrhosis mean?
It starts dying.
Dying.
It's a certain kind of death. It's a death where the liver starts to break down and form like scar tissue. It's a death of healthy tissue and a replacement of just scar tissue. Scar tissue is not functional. So basically you have a huge rock for a liver that doesn't have any stuff left in it to help you. If you have liver cirrhosis, what's going to happen to that hepatic portal vein? It's going to get blocked, right? It's not going to send any blood into the liver. So what happens to the blood? It starts to go the other way, right? That's really bad. So what happens there is blood starts to pool, it starts to go backwards. I saw a spleen the other day that was the size of a liver. Because that entire cadaver was green. The whole thing, every single tissue in that cadaver was green, because the bile was blocked up and the person had severe jaundice. But that spleen was literally the size of a liver. And a liver you have to hold with 2 hands. It's so big. So what happened was blood backed up into the spleen as well and caused an enlargement. It's called splenomegaly, or enormous spleen. What else happens is these people, as the blood starts to back up in the veins in their body, the only place it has left to go are the superficial veins in the body. Think of this; these are the deep veins. Blood continues to back up to the superficial veins, and they have what's called caput medusa. I don't know if I'm pronouncing this right, but anybody know who Medusa is?
Yeah. The little thing of this.
The Greek god with all the snakes in her hair, right? And that's what their stomach looks like. It looks like a bunch of snakes on the surface, and those are just those dilated veins because the backup of blood. So when you see that, you know things are pretty bad.
And ammonia levels go up.
Ammonia levels go up too, yeah. Why would those go up?
Because the liver's not filtering them out of the system. And once that happens, they end up going to sleep and never waking up.
Yeah, ammonia is an acid, and as soon as you get that acid-base disturbance in your body, it's
You know
all.
what's sad?
What?
There's only one med that will remove ammonia from your bloodstream if
Really?
the liver isn't working.
Really?
And guess what it is?
What?
Large doses of lactulose.
What's lactulose?
It's for someone who has bowel issues.
Mm-hmm.
Softens the stool, causes
Okay.
severe diarrhea when you have to use
Oh,
it.
well that's...
Because you're talking like 8 ounces,
Mhm.
like 4 times a day.
Mm-hmm.
And usually it's like 30 cc's, 20 cc's that you're giving
Yeah.
once a day.
So...
And it's huge doses of it. It binds with the ammonia
Uh-huh.
to excrete it through your body.
So essentially after a couple days of that, you're so dehydrated that your body shuts down anyway,
And people
right?
won't take it. They
Yeah.
just, it's that.
Yeah.
After that, I learned that 20-some years ago.
Okay.
And there still is not a med out there that has been developed to take ammonia out of the system.
Yeah, cirrhosis is untreatable unless you get a liver transplant, which is really hard to get. And if your cirrhosis is due to drinking, then you're not going to get one because some little kid with a failing liver is going to get it before you do
Right.
because they didn't drink themselves to that point. So yeah, you can die of liver cirrhosis at 30. I mean, you'd have to really be putting them down for 30 years, but it's possible.